Hello everyone and welcome to Intro to Algorithms. In this video, we will find together the answers to 5 super interesting questions. We will start with what is an algorithm? Then why should you even care? Why not just learn full stack development? Then we will find out why do big companies ask algorithms in interviews? What are some innovative products that use algorithms? And lastly, what are the correctness and performance of some algorithm? Let's start with the first question. An algorithm is a well-defined step-by-step procedure of solving a specific problem. This means that in order to have an algorithm, we should have a problem. So let's take an example. Let's say the problem is me going to the gym. Every time I go to the gym, I use the same algorithm, or let's call it routine. First, I get my gym clothes. Then, I get a towel, I get water, I drink coffee, which I don't necessarily recommend, but if you're tired, you can have a shot of coffee and then go. Then I drive to the gym or maybe walk, doesn't matter, and then of course, it's workout time. This 6 steps algorithm assures me that I am going to the gym. But of course, this doesn't mean that there is only one correct way of doing this. Some people, or even me in some days, use other algorithms. Let's take a look at the second one. Maybe the order is a little changed, so I first get a towel, then I get my clothes, then I drive to the gym, then I stop to a shop that is near the gym and I get the water from there, I don't drink any coffee because I'm not tired at all, and then it's workout time. As I said, this algorithm is also correct and it is even faster. So in those days when you want to save some time, you might want to get your water from the shop near the gym and not drink coffee in order to arrive earlier. Okay, perfect, so we know what an algorithm is, but why should you even care? Why not just learn full stack development and get that software developer engineer job anyways? Well, first, let's define your job. What exactly is your job? Your job is solving problems. Your customers or the world have some problem which need your development skills to be solved. You solve the problems, customers are happy, you get paid, and everybody wins. Cool. Now, these problems could have already been solved. For example, if you need to detect some faces in a photo, there's probably some people that already have thought about this and solved the problem, so there is a library that you can use. Or let's say your service finds the shortest route from your customer's house to another person's house. Yeah, there is surely a library that does that for you. But what happens when your needs are unique or slightly different than what existing libraries provide, if any at all? For example, the suggestions that Facebook provides. There might be some libraries that offer suggestions based on machine learning algorithms, but Facebook is surely a special one. The parameters that you need to take into account for Facebook suggestions are not found in any other library. So you surely need to understand that algorithm and build your own. The same can be for an Instagram search or any other feature. You will either need to adjust some existing libraries or build your own from scratch. Building a generic create, read, update, delete web or mobile app doesn't involve any algorithms. It is only when you have the need to innovate where this shines. And guess what? FANG companies are building innovative products and need engineers who can build them. So, why do big companies ask algorithms in interviews? Well, let's suppose they only ask questions about language or technology. Even if you are the best candidate to ever take that interview and you manage to respond well to every question, what will this prove about yourself? It will prove that you know the technology, and sometimes, believe me, there will be candidates who may know it by heart. And with today's resources and the processes that these companies have tailored to educate their engineers, everybody can learn the theory fast. So theory won't make any difference between you and any other developer who maybe worked a little bit in that technology, and is definitely not enough to make for a valuable developer. What about algorithms? What do big companies get by asking algorithms? First of all, they want to see you approaching newly seen problems. And yes, just as a note, when they started asking algorithms in coding interviews, there weren't any LeetCode or AlgoCademy, so the problems that you get were newly seen. Then they want to discuss different approaches with you, see how you would interact with a brainstorming session, how well you can articulate your ideas and present the algorithms. Because as a software developer, you are working in a team. And inside a team of different people, of different minds, you will always have different perspectives, different ideas, and different approaches. So they obviously want people who can collaborate easily with others and not just care about their own way of doing it. They also want to see your adaptability. You need to be able to see the flaws of your solution and optimize it for a specific goal. And believe me, showing adaptability is way more important than just pushing for a fastest algorithm. For example, you might want to sacrifice some speed for extensibility. And last but not least, they want to pick your brain and see how you solve a problem, that you have a clear and concise way of exposing the solution. Because they want to know that they can rely on you for your daily tasks and eventually for bigger architectural decisions down the line. Now let's take a look at some innovative products that use algorithms. Well, the short answer to that is almost all of them. But some specific examples would be Google Search, being able to autocorrect and serve you relevant content almost instantly. Google Maps directions, which use path-finding algorithms such as Dijkstra, A*, KD trees, and range search. Google Translate and dictation, being able to recognize words from voice input. Of course, the self-driving cars, the cleaning robot detecting the house map, and last but not least, SpaceX making reusable spaceships that land back on Earth. You think this would have been possible just using external libraries? Now let's discuss about the correctness and performance of some algorithm. An algorithm is correct if it gives you the desired outcome or output, no matter the input you provided with. For example, Google Maps, if you give it the map of Romania and your house and your girlfriend's house, or if you give it the map of USA and Trump's and Obama's houses, it will have the same accuracy of finding the shortest path. Now, in order to say that an algorithm is correct, we need to prove it. There are lots of algorithms which are super intuitive that they are going to be correct. For example, the sum of two numbers. If I take as input the numbers a and b and I return a plus b, of course the algorithm is going to be correct. But trust me, there are some algorithms for which the optimal solutions are very hard to prove that they are correct. One example of proof, which you can research by yourself, is of the Kruskal's algorithm for finding the minimum spanning tree. Now, what is performance? Performance is described by how fast an algorithm executes depending on the input size. The most common problem with correctness and performance is that often you can't have both. And this is especially the case of NP-complete problems. NP-complete problems can't be solved in polynomial time, so time complexities as big O of n squared or big O of n or big O of n log n. They are often solved using backtracking algorithms or brute force approaches in time complexities such as big O of 2 at power n, big O of 3 at power n, and so on and so forth. In this type of scenarios, we will need to sacrifice correctness for time. Because if we are a big company and we have an API that runs 2 at power n operations, and if n is something like 100, that means months, we would opt for a solution of big O of n cube, for example, which doesn't always provide the correct solution, but provides a solution which is 87.5% close to the optimal one. So for example, if we are Google Maps and we can't find the shortest path because it takes too long, we might want to find an almost shortest path which is 87.5% accurate, but at least it can be used by every customer. Or maybe we do some research and we find an algorithm that runs in big O of n squared, but it has only 79.2% accuracy. In this case, a decision should be made. We might want to have some hybrid algorithm, and for example, for distances which are less than x kilometers, we would want to apply the big O of n cube algorithm, and for greater distances, which means greater n's, we can apply the big O of n squared algorithm. One real example of this could be an Amazon courier which wants to deliver, let's say, 20 packages in the shortest time possible. So he needs to pick the optimal order of the packages to be delivered, which is the classical problem in theory called traveling salesman problem. This is an NP-complete problem, so there is no polynomial 100% correct algorithm found yet. So probably Amazon has made some research and has some hybrid algorithm working on that. So let's recap the main ideas that we have taken from this lesson. We have learned what is an algorithm, why algorithms are super important in tech, why algorithms are asked by big companies in tech interviews, why any innovative product uses algorithms, and what is the correctness and performance of some algorithm. This is an introduction to algorithms, and with this occasion I want you to welcome to this new world, and I'll wait you on the next lessons, which will be the intro to data structures and the complexity analysis. See you there.